Okay, everyone, Assalamu alaikum. Let's start then. We were doing coordinate geometry. Today will be the last session that we spend on this. There's one concept that we still have to do, and that's how to find angles between two lines. That is one thing that we want to do today. And then if you have any remaining questions from the worksheet, you can let me know about them. We will also be discussing those questions in today's class. So yes, let me know what problems you have from the worksheet. First of all, we will start with that. And then towards the end, we will be discussing that concept of finding angles between lines. Anyone who has any questions from the worksheet? Any questions from the coordinate geometry worksheet or from any recent papers? Let me know. No questions?
No, sir.
How many of you are done with all the assigned questions now? Can I raise of hands? Who is done with all the assigned questions? The number of questions that I asked you to do, how many of you are done with at least that number? So it was just 10 questions in total, 1935, and then 8 of this second row of questions. How many of you are done with these 10 questions? Can I have raise of hands? Okay, so that means no one is done with these 10 questions yet. Okay, so today is the last session that we have in this. I know it's easy. It's a relatively straightforward topic, so I might think that you do not need to practice much, but have you at least looked at all the questions in the worksheet? Have you at least done that? Okay, let me know then. Let me know if there are any problems. If not, we will just do the next concept then. And that will be it then, because I think you should not find anything very difficult in the rest of the questions. So if you are fine with that, that's okay. We can just move ahead and start the next topic tomorrow, inshallah, whenever you have our next class on Thursday. Just have a look at all of these questions. Okay, so yeah, so this is a relatively easier topic. So if you don't have any questions, that's all right. Let's discuss the last concept then. Let's discuss the last concept and then we wrap this topic up. Ima, you don't have any questions from any recent papers this time as well? You generally come up with some good questions from recent papers? Okay. Let's discuss the last concept then. So if there are no problems, let's start with this. Angle between lines. Finding angle between two lines. Okay, so that's the key thing that we want to do today. And that's it. So we might have a shorter class today then, because that's the main concept that we want to do. Okay, now let's say we have a line that's the x-axis. that goes like this. So this is the x-axis. So first of all, actually, let's simplify this problem and say, for now, we're looking for the angle between a line and x-axis. So that's the first thing that we want to look at. Angle between a line and x-axis. Let's see how we can find this first of all. Angle between a line and x-axis. We have this x-axis, and through this x-axis, let's say we have a line passing like this. Okay. What we are interested in is this angle theta. We want to find what this angle theta is between the line and x-axis. Now, how do we think about this? Or let me actually make it even simpler first to try to get to that standard formula. Let's make it a line like this. This is the angle that we're looking for. Let's call this angle theta. How can we find the value of this angle theta? Let's try to understand this. Let's say we know that the gradient of this line is equal to 1.5. Using this gradient, how do we find the angle that this line makes with the x-axis? We can think of it like this. We can say, let's take 2 points on the line. Let's take 2 points on the line. And let's take those 2 points like this, that one point is here, where the line intersects the x-axis. This point here. And take 1 point somewhere else. Let's say we take a point right here. Okay. Now, the first point, let's call the coordinates of that point x1, y1. Let's call the coordinates of the other point x2, y2. Now, using these points, can I make a right angle triangle like this? This triangle? In this right angle triangle, what would be the perpendicular and what would be the base? So can I figure out what this length is and what this length is? So we know the coordinates x1 and y1 and x2 and y2. So for this first point, this x coordinate is going to be x1 and the second x coordinate is going to be x2. And vertically, we know that this coordinate is y2 and this coordinate is y1. Can we write down the lengths of these two sides? Can we write down these lengths? Anyone? What are these lengths going to be?
Sir, through the formula of triangle area.
No, in terms of x1 and x2, can I write down the length of this side, the horizontal side?
Yes,
The
sir.
base is going to be
It's going to be
x2 minus x1, and the height
x.
is y2 minus y1.
Yeah, so base is going to be x2 minus x1, right? So for example, if this point was 6 and this point was 2, the x coordinate here was 6 and this was 2. What's the length of the base? It's 6 minus 2, that's 4, right? So if it's x1 and x2, we can say this is x2 minus x1. And then what about this vertical side? This is y2, this is y1. So the vertical length is going to be y2 minus y1. All right. Now, if I had to find this value theta, if I had to find the angle theta, how can I find that? I can say tan of theta, that equals perpendicular, which is y2 minus y1, over the adjacent, which is the base, which is x2 minus x1. So using this triangle, tan theta turns out to be y2 minus y1 over x2 minus x1. Now, does that remind you of something? y2 minus y1 or x2 minus x1, that's actually the formula for gradient of a line. So if you had to find the gradient of this line, that would also be the same. That will also be y2 minus y1 over x2 minus x1. This is also equal to the gradient. Now from this, we get a formula. And that formula looks like this. Tan theta equals m. That's a general formula that we get from this. That if we are looking for an angle between a line, if we're looking for the angle between a line and x-axis, we can find it like this, that theta here represents the angle between the line and the x-axis, angle between the line and the x-axis, and m represents the gradient of the line, the gradient of the line. So now, if we had to find the angle that this line with gradient 1.5 makes with the x-axis, all I have to do is, using this understanding, using this logic, we get that tan theta should equal m. We can just input values in this formula. If m equals 1.5, right, like we had there, we can find the angle between the line and the x-axis like this directly. We can say tan theta equals 1.5. And theta equals tan inverse of 1.5, which turns out to be 56.3 degrees. And that would be the angle between this line and the x-axis. So that's a formula that we have then. Tan theta equals m. You can now remember this formula. It's not given in the formula sheet. You need to memorize this. This is the logic of it. This is the background of this. But once we understand that background, now we can just memorize this formula. Tan theta equals m. Okay, where theta is the angle between the line and the x-axis, and m is the gradient of that line. If we know the gradient of a line, we can find the angle between that line and x-axis just like this. Using this formula, put that gradient in place of m and find the value of theta. Okay, is this clear to everyone? Any problem with this? Any questions on this? No? Okay, good. Let's take another example now. Let's say we have an
Sir,
x-axis that, yes?
sir, we can use this formula to find any angle on in the triangle or just one specific angle.
Only this angle. The angle that the line is making with the x-axis. The other angle would be different. This angle is going to be different.
Okay, sir. So the only x-intercept angle.
Yeah, so let me write it down here. This is the x-axis. If you have a line that's passing through the x-axis like this angle that we have here, we don't have to make a triangle. That was just to understand where this formula comes from. We could have something like this. We want to find this angle theta. Let's say the gradient of this line is 3. How do you find this angle theta? All you have to do is you say tan theta equals 3, and that gives you the value of theta. Tan inverse of 3, that gives you 71.6 degrees. That's the angle between the line and the x-axis. Okay, that's the idea.
Okay, sir.
Okay, let's take another example. You could have something like this. You have a line that now has negative gradient. Or if you have a line like this, you have this line. You want to find this angle now, angle between the line and x-axis. And now the gradient of this line is, let's say, -1/2. What do we do now? Again, the same thing as before. Tan theta equals m. Tan theta equals -1/2. Just take tan inverse of that. What do you get in this case? Your calculator is going to give you a negative angle. That's all right. I'm getting -26.57 degrees. So that's 26.6 degrees. Now what happens is, since this gradient is negative, your calculator is kind of giving you this angle, this negative angle, right? Because you're going clockwise here in this direction. This angle is given to be 26.6 degrees because you're going clockwise. It's giving you a negative angle. Now this angle is vertically opposite to this angle. So theta is also going to be 26.6. Now all that matters here is the magnitude of the angle. So even if you're getting a negative result, you just say the angle between those two lines, the line with gradient negative 1/2 and x-axis, that is just 26.6 degrees. The negative sign does not matter. We're just looking for the angle between the lines. It doesn't matter if it's positive or negative. That's not what we're concerned with. We could just write it as negative 26.6 as well. That's also acceptable. Or we could write it as positive 26.6. Both of them are going to be acceptable. Is that okay?
Yes, sir.
Now, this is one way to find the angle, as in this is the acute angle between the line and x-axis. Sometimes they can specify, find the obtuse angle between the line and x-axis. Okay, so if they say find the obtuse angle between this line and the x-axis, how would you find the obtuse angle? You would use exactly the same thing as you're doing here, nothing different. You would use the same method. Tan theta equals m. Find this angle. Now, since you're looking for obtuse angle, that means you're looking for this angle. This is also the angle between the line and x-axis. You could say 180 minus 26.6, whatever is the result that you're getting, subtract that from 180, and that will give you 153.3 degrees, like 4 degrees. This is the obtuse angle between the line and x-axis. So if they don't specify anything that they want an acute angle or an obtuse angle, you can give any of these results, and that's acceptable. But if they specify which one of the two you want, you can give acute angle as 26.6. If they want an obtuse angle instead, you subtract 26.6 from 180 to get the corresponding obtuse angle like this. The formula is the same. You just have to subtract from 180 to find the corresponding obtuse angle. Is that okay to everyone? Any problem with this? Make sense?
No, sir. Yes, sir.
Okay. Now, here we are just finding the angle between a line and x-axis. Now, a lot of times what happens is we want to find angle between two lines. So we want to find angle between two lines. So for instance, you could have a line that looks like this. Sorry, let me draw two general lines. Let's say we have a line that looks like this. This has a gradient of, let's say, 2. That's one line. And we have another line, let's say that looks like this. And this line has a gradient of 1/4. What we are interested in is the angle between the two lines. We want to find the angle between these two lines. Now, how can we think about this? One possibility is that we use the same formula that we used before. What was that? Find the angle between the lines and x-axis instead. So at the point where the lines are intersecting, where are they intersecting? At this point here in the middle, you draw this horizontal line. Okay, at the point where the lines are intersecting with each other, draw a horizontal line here. Now what you can do is you can find the angle between this upper line and this horizontal line using that formula, and you can find the angle between this lower line and the horizontal line. You can find these two angles individually. How can you do that? Let's call this M1, let's call this M2. So the upper line is L1, let's say this line is L2. Let's call this θ1 and this θ2. We are interested in is the angle between these two lines, this angle here, right? what we can do is we can say, let's find each of those angles separately. Tan theta 1 equals 2 and tan theta 2 equals 1 over 4. Using the same formula that we used above, find these two angles. What do we get? We get some value of theta 1 from this. Tan inverse of 2, that is giving me 63.43 degrees. And similarly, I can get some value of theta 2 from this. Tan inverse of 0.25, that is 14.04 degrees. And then the angle that I was actually looking for was the angle between these two lines. That's this angle. How can I find this angle? Theta in this case is just going to be theta 1 minus theta 2. It's the difference between those two angles. That's all you do. You say this is 63.43 degrees minus 14.04 degrees, and that will give you the result. 63.43 minus the answer, that's giving me 49.39 degrees. That's the angle between these two lines. Is that okay? So you find one angle with the x-axis, find the other angle with the x-axis, then just subtract the two values. That is one way of doing this. However, it does cause some confusion sometimes. You have to think a bit carefully when one of the lines is like this and the other is like this. And you have to be a bit careful how to actually find that angle. Although it's not that difficult as well, but a lot of students find it easier to use another formula that we have for finding angle between two lines directly. So it's derived from this same formula, tan theta equals m. This is the formula that we're getting for the gradient. What are we doing here? To find angle between two lines, we're finding one angle and subtracting from that the other angle. This process can actually be generalized to get to a direct formula that looks like this for angle between two lines. And that formula looks like this: tan theta, that equals m1 minus m2 divided by 1 plus m1 into m2. That is the formula that we can use to find angle between any two lines. So in this case, theta represents, in this formula, theta represents angle between any two lines. One line does not necessarily have to be the x-axis in this case. It could be any two lines. Okay. And m1 here represents gradient of the first line, and m2 represents the gradient of the second line. Okay, that's a direct formula that we can use. Tan theta equals m1 minus m2 divided by 1 plus m1 into m2. Now, those of you are interested, this actually comes from that tan identity. You can look it up. Some of you haven't done paper 3 yet. In paper 3, you will be doing this identity, tan of a minus b. That can be written as tan of a minus tan of b divided by 1 plus tan a into tan b. That is where this formula is derived from, by first using this formula and then using that identity to basically get to this formula. Now, you can see it looks very similar. In this identity, you have tan a minus tan b. Here you have m1 minus m2. In the denominator, you have 1 plus m1 m2. Here you have 1 plus tan a tan b, because that's where the formula comes from. Okay. In fact, if you forget the formula, and a lot of people end up forgetting this formula in the exam, they mix up these signs, that whether we have a minus sign there or a plus sign there. what you can do is just look at the formula sheet on the trigonometry page. You get the same formula sheet for paper 1, paper 3, all the papers, you get the same formula sheet. On the trigonometry page, if you look at this compound angle identity for tan, let me see if I can find that somewhere. If you look at this compound, this identity for tan of A minus B, this one. In fact, I think that's not going to be helpful, because if you have it in paper 3, you'll be confused. Why do we have these plus minus signs there? Forget about it. I'm sorry. Forget about that. Just remember it. Just memorize it like you normally would. You have this formula for angle between two lines. Okay, that's where this comes from. Tan of A minus B, that's identical to tan of A minus tan B over tan 1 plus tan A tan B. You would realize this later in paper 3. This is an identity that we use for compound angles for tan. That's where this formula comes from. But now you just need to memorize this. This is the formula that you can use to find angle between any two lines. Tan theta equals m1 minus m2 divided by 1 plus m1 m2. In the numerator, you have a negative sign. In the denominator, you have a positive sign. Okay, so now you will memorize this formula. In order to find angle between any two lines, you will just use this directly. Now, let's use this formula, first of all, to find angle between these two lines that we had in that previous example. How could we use this formula to find that angle directly? Let's try to understand this. We have two angles given, two gradients given. We are interested in finding this angle, the angle between these two lines. This is the angle that we're interested in. Now, we could get this angle or sometimes this angle. It depends on which one you take as M1, which one you take as M2. It doesn't really matter. You'll get either an obtuse angle or an acute angle. Both of them are going to be acceptable. How do you find the gradient? You would say tan theta, that is equal to M1 minus M2 divided by 1 plus M1 into M2. Just input values in the formula. That's all that you have to do. Let's call this M1, that's 2. That gives you 2 minus M2, which is 1 over 4, divided by 1 plus M1, which is 2 into 1 over 4. Okay, and that equals tan of theta. Now, let's simplify the right-hand side. What do you get from that? Tan theta equals 2 minus 1 over 4. That's going to give you 7 over 4. In the denominator, you have 1 plus 1 over 2. That's 3 over 2. You can simplify this if you want, or you can just put this directly on your calculator. If you simplify the right-hand side, it will turn out to be 7 over 6, I think, right? And then you can find the value of theta from this. Just do tan inverse of 7 over 6 and see what that gives you. Tan inverse of 7 over 6, that's giving me 49.398. That's 49.4 degrees. And that's exactly what we found here as well. 49.39, if you were to round that off, that gives you 49.4 degrees. That's the angle that we can get using this formula directly. Okay, theta equals 49.4 degrees. This angle is 49.4 degrees. Now, even if you interchange M1 and M2, that's not going to be that much of a problem, because if you do interchange them, you can try that. You can try 1 over 4 minus 2 divided by 1 plus 1 over 4 into 2, as in you can take 1 over 4 as M1, you can take 2 as M2. It doesn't make any difference. At the end, you would end up getting theta equal to 130.6 in this case. And that's also fine, because that is giving you this obtuse angle. That angle is 130.6 degrees. Okay, so you can write any one of those two. Both are going to be acceptable. If they specify that you want an acute angle or an obtuse angle, then you just subtract from 180 to get the other one. If you're getting acute, you can find obtuse by subtracting from 180, and also the other way around like that. Make sense? Any problem with this? So you should now remember these formulas. Okay, they're going to be helpful. One is tan theta equals m. This works when you're finding the angle between a line and x-axis. And this is a general formula that can work for any two lines. One of them does not necessarily have to be x-axis in this case. If one of them was x-axis, you can see what that turns out to be. If one of them was x-axis, then m2, let's say, is 0, right? One of these gradient would be 0 for x-axis. It would become m1 minus 0 over 1 plus 0, and that will give you m1. And that gives you the first formula, right? So even if it's x-axis, you can use this formula, but it's a more general formula that works for any two lines, okay? So for x-axis and a line, we use tan theta equals m. For angle between any two lines, you use this formula. Make sense? Any questions on this? No? Okay, let's just do one more example then. Let's say we have two lines. We have line 1, let's call that line L. It has a gradient of -6. And we have another line M, it has a gradient of, let's say, 5 over 3. We want to find angle between these two lines. Okay, that's going to be a problem. M and M, let's call this L1 and L2 instead. We want to find angle between these two lines. How do you do that? You can use the formula. The formula is tan theta equals M1 minus M2 divided by 1 plus M1 into M2. Again, you can call any of them M1, any of them M2. Let's say this is M1, the first one. That gives you -6 minus 5 over 3 divided by 1 plus -6 into 5 over 3. Tan theta equals this. Let's simplify this. That gives us tan theta equals -6 minus 5 divided by 3. That's giving me -23 over 3, the numerator. We just evaluate that whole thing in the denominator. We would have 1 minus 10. And that's giving me tan theta equal to 0.85185. That's what tan theta turns out to be. Now we can just take tan inverse of that and see what that gives us. Tan inverse of this number, that's giving me 40.4 degrees. So that would be the angle between these two lines, 40.4 degrees. That's the acute angle. If you were looking for obtuse angle, just subtract that from 180. Make sense? No problems on this? Sure. Any other questions from the worksheet or otherwise? Does anyone have any problems? Okay, so we're going to keep it to this then for today. I was expecting to do some questions as well. If you had any problems, but if there are no problems, that's it then. That completes this part of coordinate geometry. And we still have equation of circle left. We will be doing that later. In the next class, we are starting differentiation. Okay, so on Thursday, we start differentiation, inshallah. And you can also expect, although I'll confirm this, but you can expect an extra class this Friday or Saturday as well. So keep that in mind, most likely Friday. Do expect an extra class as well. Okay, so we will be starting differentiation in the next session, and then integration, functions, and APGP. So we still have quite a few topics to do. We will need to speed up now. But that's it for today. Okay. If anyone has any questions apart from coordinate geometry as well, you can let me know. We can maybe discuss that. Because it's not going to be helpful to start the next topic right now, because we will not be able to do much. If you have any other questions, from any topics. We can maybe just discuss one random question from anywhere if you have it. No?
Sir,
Yes, Abdullah.
sir, I have seen that most of the coordinate geometry questions are asked with differentiation.
Not most, but yeah, many times. But you do get a separate question on coordinate geometry as well. In differentiation, you do have a lot of coordinate geometry involved, yes, but you have a separate question on coordinate geometry as well apart from that. Okay. So it's mostly with equation of circle that happens as well. That's actually part of coordinate geometry. But you get separate questions as well, where you have to all of these examples that we did in this worksheet, they're all from past papers. So you do get questions only on coordinate geometry like this as well. Okay. Anything else?
Sir, I have problems solving entire past papers whenever I revise. Do you have any advice for that? I always get confused between which topic to actually, which topic the question is actually asking.
Generally, that confusion occurs with quadratic sometimes. Sometimes in some problems you have to use discriminant. That's not very obvious sometimes. But apart from that, I don't see which topics you would be confused in as such. Yes, the concept of discriminant sometimes comes in topics that you don't generally expect it to come with. So sometimes in trigonometry they end up using discriminant as well with the quadratic equation. But where else do you get confused apart from that? Which topics do you get confused in?
It happens to me in S1 generally, not really P1.
Yeah, so should not happen in P1 generally. In S1, yes. In S1, representation of data is very clear. Probability and permutation combination questions, they are kind of combined a lot of times. So in probability questions, sometimes you have multiple methods of doing that. Sometimes you can do that using probability only. Sometimes you can take help from permutation combination concepts there as well. And there are alternative methods that use permutation combinations. So that's where confusion can occur sometimes. But again, I don't see anywhere else this problem occurring because if you remember your binomial conditions well, your geometric distribution conditions well, then that problem should not occur. So in order to avoid that, you need to make sure that you memorize all of those conditions. When do you have binomial distribution? When do you have geometric distribution? What are the conditions for that? And then apply those conditions on the question to see which one of the distribution it's going to be, if any of them is there. Because apart from that, a normal distribution question would always tell you it's normal distribution, right? Probability will be clear as well. In probability, you do need to use other topics sometimes. That is where confusion can be. But apart from that, make sure that you remember the conditions well for binomial and geometric to figure out which one of those distributions applies, and that should most likely help. But again, you get better at this with practice. So just keep doing it, and you will get better at it as well with time. So maybe after a week or a couple of weeks of practice, you will be finding it easier to figure out which topic the question is referring to. Yes, Rizal, from Monday we will be following Ramadan timings. So most likely I will be posting a poll today. I'll try to do it by tonight to finalize the time. If not tonight, then definitely tomorrow, inshallah. I'm going to try and finalize the possible schedules and then ask you guys. So tonight or tomorrow. From next week, yes, we are going to be following the new schedule that we will decide based on what you guys prefer, what most of you prefer. Okay, anything else? Anything else?
No, sir.
No? Okay, all right. So we're going to end this here then. Will the days be the same? Well, so the two schedules that I'm going to share, they're going to have different days. So if we do it the same days, then the possible timings that we can do in these days is at night, 10 to 12 type. If we do afternoon, then 2 days are definitely going to be Friday and Saturday. And then along with those 2 days, we would have either Tuesday or Wednesday. So Friday and Saturday, and then along with that, Tuesday or Wednesday, or maybe in some weeks, both of them, because we are going to need some extra classes as well. So keep that in mind. We might have 4 classes some days as well, some weeks as well. So if we have afternoon, it would be Friday, Saturday, along with possibly Tuesday and Wednesday. And if we have classes at night instead, in that case, it would most likely be Monday and Thursday, definitely, and then 2 other days. So again, I'll post all of that. Then you can give your votes according to that. In the Middle East, it's off on Fridays and Saturdays, right? Is that correct?
Friday is half days.
Friday is half day, and then Saturday is off.
Yes, sir.
Okay, all right. So what about your school classes, by the way? Is anyone still going to school for anything? Or are you done with your syllabus at school? Or are you still going to school?
Yes, sir.
Okay, who has mocks going on right now? Can I raise a hands if you have mock exams going on right now? Anyone who has mock exams going on right now? Anyone who will have mocks starting in the next week or so? Who has mocks in March at some point? 21st March? Arham? Okay. Abdullah, when do your mock start?
Sir, in second week of March.
Second week of March. Okay. And for the rest of you? Aisha, Aima, Naima, Rajal, you don't have any exams this month?
No, sir.
Okay. Naima, do you have any exams? What did you say yes to? Do you have exams or don't have exams? You actually messaged in the wrong window, so I missed that at that point. Okay, all right. So I think that's going to be workable then if we do either afternoon or at night. If you don't have school anymore, most of you, then it should not be a problem, hopefully. And your exams are starting after maybe 14th and 15th as well. We would just have a couple of weeks left after that, so I think it's going to work. Okay, all right. I'll post that on the group then, and then we'll finalize it in a couple of days as well. Please also do something about these worksheet submissions. Start submitting them if you haven't been doing that. That is extremely important. Otherwise, you just keep forgetting stuff. Keep revising everything over and over again, because it's very common in A-levels that you are about to approach exams sometimes, as in you have exams in 2 weeks and then you realize, okay, you've forgotten everything. You don't want that to happen. And the way to avoid that is that you keep revising what you've covered before. Okay, make sure that you keep doing revision. Keep going over the notes and the questions that you've already attempted. At least that much you should be doing regularly so that you don't forget everything. Okay. All right. Allah Hafiz then. I'll see you again in the next class. Bye.
Love, sir.
Allah Hafiz.